Hi, this is Parsh Gupta and I will be presenting about the DETERLab tutorial core guide. I have already set up everything, the experiments, so that it's easier and faster for the demo. So after logging into the DETERLab, and we have to essentially go on begin an experiment, select the NS file, give the bunch of settings, and try to set up the network topology to perform various experiments. So here, as you see, I have already set up the NS file, and here's a network topology which I had set up, which has 4 nodes, as you can see, A, B, C, D, along with a connection here. This NS file is the basic NS file which is provided in the core guide here, but I have made some changes, especially demonstrating the NS file possible configurations, just to show you what you can do while you are setting up the topology and the nodes. If you open this NS file section, you will see this is the NS file, and the changes which I have made are essentially these two lines. I'll be going over what exactly these two lines do as I present about the core guide. So after setting up the experiment in the DETERLab, for setting up the experiment, the most important thing which you should be aware about is the NS file and the various commands and how you're supposed to write it. So if you open this NS file right here, you'll see a bunch of statements which looks little like a TCL command, and in this file you'll see what exactly you are supposed to write to accomplish a set of given tasks in a network. So as you see, I have set up 4 nodes A, B, and C, D. This particular, if you see this $NS node, this is kind of a placeholder. When the program configures and emulation happens, they are replaced with the actual value. Here as you see, the link which I was talking about, this link is set up, and it specifies between A and B you have to make a link which is not the default one, which is like a 100 Mbps connection. Here it will have a 30 Mbps connection with 50 millisecond latency. So basically there's a link loss. That's what you specify between node A and node B, as you can see here. Moving ahead, you can also specify which kinds of OS you want in your nodes as they start up. You basically specify the image of the operating system you want the nodes to be loaded with. So here, as you see, you specify BSD, FreeBSD. By default, they are loaded with Ubuntu, the latest version. There are a couple of options, basically a string which you need to specify here if you want a specific OS. As you can see, node A and node C will be loaded with FreeBSD. The others, which are B and D, will be loaded with Ubuntu. So this is the enhancement compared to the basic NS file which is present in the core guide. Essentially, this particular command allows me to specify, okay, in node A, you need, as the node gets started up, the tar file should be extracted into this particular folder. This is particularly useful if you want to do like a boot up kind of a thing. As the node starts up, you want to boot some program, or you want to install some applications as the node is getting started. So that is particularly useful. The other one is kind of similar. Instead of tarring, you can also specify any application which you want to run. So I have specified in node B, Python script should run. So Python and the path. So important thing to know is there are only particular folders where you're supposed to keep your files. So under project directory we have this E542 directory, and uh, it's a good idea to keep those files here. Otherwise, as the nodes are swapped in and swapped out and experiments are conducted, the files may get lost. So I have kept my file just for demonstration in this directory, the Python file as well. The last one is essentially which specifies what kind of protocol you want to use. You want your own protocol, as in manually configure all the links yourself, or you want it to be taken care automatically. So basically there are four options, if you can see from here: session, static code, and manual. I'll be also demonstrating manual routing and how that works. But for sorry, but for this first experiment, as you can see, it's static. So DETERLab is automatically taking care of it. So once this NS file is set up and the experiment is load swapped in, you'll get an email from ISI saying, okay, the experiment is loaded in. So you'll get an email like that, which will describe the OS, uh, which particular physical PC it is assigned to, and other network parameters as well. So link and IP, the MAC address as well. So you'll get a detailed email about everything. Next, what you can just do is just SSH into first this user's So once you SSH in this particular URL, you can now log into your nodes. So I'll just log in my node A. So I log in, and node A was set up with FreeBSD. So if you see, this is FreeBSD install. And what I particularly wanted to show was, as per the NS file, it says in node A under user site, you should have this untarred. So if I go to that particular directory, so this untar.txt is present. If the which is the content of the test.tar file, and similarly I can just SSH to node B, and see the output of the log file which was supposed to be generated. So it says hello from node B. This was just a demonstration, just a small script which I had written, so I can just show you what the script was doing. Oh, sorry, I should do cat. So yeah, that script was supposed to just print something on standard out, hello from node B, which is present from in this particular path. And as you see, it's supposed to print everything to this particular file, and I did that here in this particular nodes temp and foo.log file. Similarly, I can just yeah, so that's on the basic NS file and the features which are possible by DETER, the NS file, the basic configurations. On the other hand, I also wanted to demonstrate the manual routing. So I have already also set up another experiment which you can see here. These are basically three nodes connected together, but they are not connected via static command. They are like manually connected. Unlike here, as you can see, this is static, and this it's manual. So, so there are a couple of ways you can specify link. So the basic format is you have to specify the client, and then it's like adding route, and then specify the destination and any hops in between. And the other method is you specify the link name itself, and the other one the server LAN. So what happens is, this is a particularly good example of demonstrating how using manual routing is sort of difficult, particularly for a network topology which contains more nodes, because you have to describe all the links yourself manually. So as you can see here, if I want to specify, if I write something like node A add route node TP, which means I want to connect node A and node D, and the immediate hop is node B. But what happens is, the program which runs on the DETERLab won't be able to identify, okay, on B which node you want, node. So basically, because, sorry, let me just scroll back up. So basically, the program will not be able to identify which of the links you are talking about which is connected to node D, because D is connected to C as well as E. So it will be difficult, and the program will basically error out. You will get an error saying this network topology cannot be created, check your NS file. An easy way would be to do something like this, which was the second way here, add route link server route. So here if you see, it says node A wants to connect to node B, but in between there's a link which connects node D and node C. So yeah, you can hand route manually any network topology you want, but keep in mind, as the number of nodes increases, there's a possibility you will miss out on a particular node being connected to the network or messing up the whole configuration. So that's how the DETERLab works, and basically all you need to know how is to create the NS file for your particular experiment. That's about it. Thank you. This is Parsh.